Yes, sir. Thank you for that introduction. And yes, thank you for your all of your cooperation in setting this whole lecture series up. Uh, yeah, I think you said many right things there. I mean, the EC department, we all know that it is a really good department and it has a really strong alumni network. So yes, being also an alumnus, I'm very excited to share these things with you. And the reason why I want to share these things uh, is I think it is going to be a very important skill set in the future. Um, and it's not like I'm saying that everybody who goes in EC or computer science should just do computer vision, robotics, and things like that. But this will be a nice addition to. It can be your full resume, or it could be a very nice addition to your skill set, and it will definitely make you more employable in the future workplace. I think everybody is hearing stories in the news every day about how artificial intelligence, machine learning, Internet of Things. We are hearing all these buzzwords, and they are definitely going to get more and more important. So I think it's important for students to also learn these skills. And I also want to mention one thing. Yes, I was, in fact, when I did my 8th semester project in the department in 2011 and 12. In fact, my colleague, my teammate Rakshit's project was on computer vision, and at that time it wasn't such a big field, but we learned a lot from that, and we also got a lot of encouragement and support and guidance from Professor Tanish Zaveri, who very unfortunately has passed away now. And so I also want to remember him and basically, uh, um, yeah, remember him fondly before starting this lecture series. Because all of us from our batch, we certainly benefited a lot from his guidance. Um, yeah, so with that, I'm basically saying that yes, it is going to be an important skill for the workplace, and that's why we all should know something about computer vision, robotics, machine learning. And today's lecture, so it's a part of 6 lectures, but today's lecture is not going to be about any technical topics. It's just going to be about motivation and some trends and things like that, and what the future plan is. So maybe today's lecture is going to be short, but I think the next 5 will be about 1 hour. And yeah, I mean, my actually, I don't have any expectation. The only thing is, if you have questions, then just unmute yourself and ask those questions. As Sir said, don't think any question is good or bad or silly or intelligent. I'm happy to answer all questions, and that will also give me really good indication whether I'm going fast or slow, or do I need to change some of my material and things like that. So it will also be very helpful for me. Um, Yeah, so it is going to be an important skill for the future workplace, and we can already see that in the news. So, for example, the Niti Aayog, which basically decides central government policies for the future, they now have a national strategy on artificial intelligence. And that is not unique. In fact, a lot of big countries all around the world have these strategies. Um, and there are lots of debates every day uh, about how we should regulate artificial intelligence, how we should develop more skills, how we should develop more researchers, and there are lots of debates about data, where data should live and things like that. So this is definitely a big topic in the news these days, and it is all we also see it from the economic point of view. There are huge amounts of investments being made in all these things, which means a large number of jobs are going to be generated. And a lot of those jobs are also being generated, or in the future, they will be generated in India as well, in all the software industries. So in the big software industries in India, as well as a lot of startups, right? So there are, yeah, in fact, basically there's a huge amount of data being generated in India, and there are lots of potential ways to apply all these techniques. So I think if you know these skills, then it will definitely make you more employable after you graduate. So these are just some news articles that I found. There are so many others about millions of dollars of investment in startups and big industries. And another thing I want to mention is in this course, in this lecture series, I'm not going to teach you everything about these topics. So it's not equivalent of, for example, taking a whole semester's course, official course. My objective is to give you some basic knowledge so that you you know which papers to start looking, you know how to read papers, you know which open source repositories to use. You can get started with tinkering around with various projects. When you read press releases from all these big companies like, I don't know, Google or OpenAI or Facebook, and so then you actually know what is going on technically behind all these fancy videos, and what it takes to do all those things. Uh, and specifically, I know there are some students from different semesters, but for students who are in the seventh semester also, I think one of my motivations is to inspire some of you to do your eighth semester project in this area. And as sir said, we are definitely planning to set up a laboratory with some equipment and things like that. But uh, that will take some time to set up. But definitely there are some things that you can just start with your laptop and do a nice project in that area. And another really interesting thing about artificial intelligence is that uh, it's kind of like mathematics, because you can have mathematics in various different things, right? You can have mathematics in electronics, you can have mathematics for physics, for chemistry, uh, you can have mathematics for mechanical design, all kinds of things. So I think in the future, and already in the present, we are seeing that artificial intelligence is being used for everything. So there's artificial intelligence in healthcare, in social networks, in uh, basically every field that you can imagine. There is going to be artificial intelligence in cars, in movies. uh, I mean, there are just countless examples. It's like a basic skill that can help you in no matter in which field you want to go. People are also designing and discovering new drugs and new medicines using artificial intelligence. People are using it to understand uh, people are using it to understand uh, like astronomy and like basic fundamental physics and things like that. And it's just becoming a sort of a very basic skill that is useful. So there's another graph, a very interesting graph about the investments going into artificial intelligence inside India. So you see that as this is basically just projected investments. So right now it's 2021, but the investment is going to increase and increase unless there is a big disruption. So uh, because there is going to be investment, there's going to be lots of new jobs in this area as well. Okay, and so those were some statistics about jobs. If you want to continue for higher education, there are some data there as well. I couldn't find easily some data about PhDs inside India, but for example, if you look at computer science PhDs in the United States, then you can see from this graph that uh, as the years increase, the percentage of computer science PhDs who are doing their PhD in artificial intelligence or machine learning is just increasing very quickly. And recently we are seeing that increase also in robotics. So computer science, as you know, is such a vast field, right? And if 23 percentage of all PhDs in computer science are doing artificial intelligence, that means it is a big subfield of computer science. And as I said, people are applying artificial intelligence in all other different branches of computer science as well. So yes, if you want to do higher education, then also there are lots of research opportunities and things like that in this area. Another graph about research. So these are the number of papers that were published in a big computer vision conference called CVPR in 2020. So this graph is taken from 2020, but you can just see that starting from 2011 to, if you look at 2020, the number of papers submitted to that conference is just increasing exponentially. I think after 2016, the increase is just phenomenal. And I think actually this 2021 version of CVPR is happening right now in the next 2 or 3 days. So I expect that we will see even a bigger jump there. Yeah, so those were just some motivating points. Actually, I don't think I needed to motivate, but just for the sake of completeness, I think all of you know that these are going to be the trends of the future. And again, I want to repeat that uh, it does not mean that everyone has to. It does not mean that all other branches will go down. It's just that artificial intelligence and machine learning can become a basic skill which will make you even more productive in other fields. Like you can use it, uh, for example, you can use it to design even better and more efficient communication networks. It can help you in networking. You can use it to design all sorts of things. You can use it to design more efficient chemical reactions and things like that. So yeah. And then just to make it more relatable, I also want to spend some time talking about uh, very concrete real world examples, how people are using computer vision, uh, machine learning, things like that. So machine learning, uh, I guess artificial intelligence and machine learning are in my mind, I think they're kind of synonyms. So I'll just use machine learning. Machine learning is sort of a recent trend, but cameras have been around for a long time. So people have been using computer vision techniques in a lot of applications. Of course, all of you know these QR codes, for example, all these Paytm and all those apps. These QR codes are everywhere, and in fact, that is a very good example of a um, very well working example of computer vision, because basically it is looking at the image and finding out the various corners in this thing, and the locations of those corners allows it to convert that to uh, some other text that text can be a link, or it can be some other text as well. So for example, these kinds of technologies were being researched 10-15 years ago, and now after so much research they have become so robust, and they work so well that now you can have it working on your phone. and you can look at it from all different angles. You can look at it from different lighting conditions and things like that, and it will immediately recognize the QR code. Um, I am also sort of, I have a soft spot for space technology, and I just want to also give some examples of examples of how computer vision is being used in space. So, for example, we all know about Chandrayaan, uh, which was the lander. I mean, the Vikram lander was going to go down on the surface of the moon. And actually, if you look at the technology behind it, uh, how they control its descent to the surface of the moon, then computer vision becomes very important. So there is a screenshot from a paper written by ISRO scientists, and and basically the problem is that as it is going down, it needs to it needs to stay upright, right? So it has some, it has all its thrusters and things like that facing downwards. So you need it to continue facing downwards. It shouldn't kind of go sideways and things like that. So you need to have a precise angle control, and you also need to know how fast you are going down, so that you can slow down, control your speed and things like that. And so unfortunately, because of a problem with the one of the thrusters, uh, it actually crashed. But the technology that it was using to know how fast it is going, to know what its angle is, it uses a lot of computer vision. For example, they have the orbital high resolution camera, um, which is used for characterization of landing site. What does that mean? So that means that before, using previously created maps of the surface of the moon, they've decided a particular site of landing. So then when the orbiter is when the lander is, like, maybe a few 100 kilometers above the surface, it starts scanning the surface from its camera and matching it with the previous maps that it has, so that it knows that it is correctly above the landing site. Uh, and then when it's nearing the surface, it can use these cameras also for uh, knowing the horizontal velocity of of the lander, um, and also position estimation of the lander. And of course, these cameras are not the only sensors. So it has a lot of other sensors. So for example, it has accelerometers, inertial reference unit. These are all things like gyroscopes and things like that, which also give you information about rotational velocity and things like that. So in computer vision, the kinds of problems are just looking at images, or maybe a video of images. From that video of images, you need to figure out how fast your camera is moving, in which direction it is moving, and things like that. But of course, that is not the only sensor. So in robotics, you will see these kinds of problems where you are trying to combine the readings from many different kinds of sensors, and all these different sensors have different kinds of uh, plus and minus points. So, for example, you have all these accelerometers, gyroscopes, and the cameras. They're all giving you ultimately information about speed and angle, and those informations are they have noise in different characteristics. So by combining them, you can have a very accurate measurement of your angle and speed and things like that. So those kinds of problems come up in robotics, and cameras and computer vision are one of the important sensors that are used in robotics. Uh, so if you to give a actually a concrete example of what I talked about before, there's that concept is called visual inertial odometry. So as you know every car has an odometer. So odometry basically means knowing your own motion, right? So I just want to show you this demo video from a research paper, uh, where you can see that they are getting all these images from the cameras that are on a drone, right? and in those images they are able to let me actually, sir, or anybody, can you see the video smoothly, or is it uh, okay? You can see the video
Yes,
smoothly.
we can see
Okay.
the video.
Yes.
Okay. Because sometimes in these video calls you need to do some special settings so that videos are smooth. But if it's smooth, that's fine. So I can pause it at one frame and show you. So if you see, there is this red, green, and blue 3D coordinate axes that are moving around, and that shows uh, from these images the motion of the camera that they are calculating using this visual inertial odometry, right? So visual in this thing means from the cameras, and inertial means all those accelerometers and gyroscopes. So they are combining readings from all those, and they are deriving this motion of the drone, or I think maybe it's just a camera. So you can see this one. So there's actually a camera fitted on a plane or something like that, and they are using it to derive the motion of the plane. So this is exactly the kind of technology that they were using also on that Vikram lander. So you can track. Yes, the concept of SLAM is very very related to that. So in SLAM, there is also the mapping component where you have to derive your camera motion and a map of the environment at the same time. And in this odometry, uh, it's not so much of a mapping. It's just you are moving, and then from maybe the set of 4 or 5 current images, you just figure out how much you moved in this 5 milliseconds or things like that, and then you just keep on adding that movement so that you get the whole trajectory. So yeah, you can see, so it is moving around. This is actually a drone, and it is able to track the motion of that drone. Okay, so yeah, there is one example, and this kind of example is very very common. So this technology is used, as I said, in spacecraft, in self-driving cars, in all these augmented reality, there are apps that you have on your phone, things like that. Another example I want to show you is more related to what is called computational photography. So the idea is you're taking a series of photographs, but then you're using some geometry, trigonometry, and computer vision, things like that, to combine all those photographs. So you might have seen these videos, selfies of the Mars rovers from NASA. But this video actually shows how they do that. Right, so this video is being taken from a camera, so that camera is not seen in the video, but what you're seeing here is one of the arms of that Mars rover that has another camera that they pointed with the arrow, and so it's taking all these pictures. But if you look at this thing over here, so there are all these different markings everywhere all along all this machinery, and these markings are uh, there for calibration. So it can look at these markings from the camera that it's recording this video from, and these markings are designed such that uh, and we will cover this in lecture number 3. If you recognize these different points in the image, then using some trigonometry you can actually calculate the position and angle of that marker with respect to your camera. So that allows you to calibrate And by calibrate, I mean that allows you to know exactly the position of the arm when it was taking each photograph. And if you know the position of the arm, and the camera and the arm camera is basically fixed to the arm, so then you know the position of the camera as it is taking each photograph, right? So then basically you can use similar technology to you have all these panorama apps on your phone also, so then you can use that information to combine all the different photographs. It's taking all these photos, and ultimately it takes a lot of photos, maybe more than 100 photos, and it gets a very high resolution combination of all those photographs to kind of create a selfie like that. Okay, so those were some very traditional computer vision applications. There wasn't any machine learning or anything in that. So in this video is more about robotics and machine learning. So let me actually first just show the video. So you all know about this Rubik's Cube, right? So here the different fingers have these lights which allows external camera to track the different fingers and know where those fingers are. And the task of this robot is to move the fingers so that ultimately the Rubik's Cube is solved. Right? Now, solving a Rubik's Cube is a skill. You have to learn that skill. So that is where the machine learning part comes in. And the very interesting thing here is the way they learned the skill of solving Rubik's Cube is completely in simulation, right? So in a simulator just inside a computer, they created a model of this arm, of this hand and all these fingers and things like that. And they created a model of the Rubik's Cube, and they have some physics. They have some program that calculates all the physics. So if the finger moves like this, then it will exert this much force on the Rubik's Cube, and it will make the Rubik's Cube move in a certain direction and things like that. So completely in the simulator, they just made it play in the simulator again and again, millions and millions of times, and sort of in a process kind of similar to how babies learn different skills. This algorithm in the simulator learned how to solve Rubik's Cube, and then they put this algorithm on this robot, and the robot actually has the same, like the robot fingers and everything moves in a way similar to the simulator. So now if it applies the skills that it learns in the simulator, then it will actually solve the Rubik's Cube in the real world. So this technique is called reinforcement learning, and it's a part of all this AI, machine learning, things like that. And it can actually solve it with lots of different adversarial conditions, like if you put different, if you distribute in different ways and things like that, it is still able to solve the Rubik. Okay, so that was more on the robotics and machine learning side. As I said, computer vision, things like that are being used in healthcare as well. So this is a video from so actually, can you also hear the sound from the video?
No, sound is not there.
So for that, Samarth, for that, what you need to do is when you are sharing down your screen, when you open up that share option, on the left hand side there would be a drop box which says that if you want to optimize your sharing for video and audio. So just select that option, and will be able to see the audio as well. Sorry, listen to the audio as well.
Okay, so let me stop sharing and I'll restart the sharing with that option.
What have you been doing since TEDx Gateway 2011?
So, Ralph, there are 300 million people in India who need glasses but don't have them. So my group at MIT Media Lab invented a very new solution called Inertial, which is a phone that's snapped into a binocular. You look through it, click on a few buttons, hit calculate, and it gives you a prescription for your eyeglasses.
Oh.
Your nearsightedness, farsightedness, and astigmatism. And Yashraj invited me to present this technology in 2011 right here on this stage. And I made an appeal right.
Samarth, you are not audible. No, still you are not audible. I think you have muted yourself. Sachin, are you able to listen him?
No, sir. No, no.
We have no, we have lost the audio.
Dr. Samarth, I think while resharing, you have to share in normal mode. Do not optimize for sound and audio. Then I think we can hear your audio.
Okay, can you hear me now?
Yes, you are audible.
Okay. Yeah, sorry for that. So basically, I just wanted to show you the first few seconds of that video. And they're using computer vision to look into your eyes and figure out from that, you know, the numbers of your glasses that you need. So this is, you know, I just wanted to show you an example that these technologies are not just used for, you know, like high technology and fancy things, you know, space exploration and 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 very fancy technologies like solving Rubik's cube and things. These are actually things that can be used for, you know, very relevant applications at for a large number of people, and they can actually help a large number of people. So again, people are also using it in agriculture. For example, I found there's this research institute called Vadhwani AI that is using, or at least they're planning to use computer vision to figure out the number of pests and insects inside cotton and things like that. So I think, yeah, it can be applied in a wide spectrum of different areas, right? So ranging from agriculture to space exploration. So yeah, with that, those were all sort of my motivating examples. You know, whatever you want to do in life, whether you want to have a job or you want to do research and sort of get a PhD and things like that, or you want to and in different fields that you want to work in, everywhere these skills can be helpful. So yeah, so with that, I think I will just near the end of my presentation today and just present the plan of the lectures. So I divided up into 3 different parts. The blue parts are sort of what we call traditional computer vision. Green parts are more focused on machine learning, and the red part is about robotics. So we are going to talk right from the basics, like how is an image, which is a 2D quantity, which is formed from a 3D world. So what is this mathematical function that converts a 3D world into a 2D image? And if you have a 2D image, how do you store it inside a computer and things like that? And then we will talk about cameras. So we'll discuss some uh, basic models of cameras. So for example, how can you actually calibrate a camera? So by calibration, I mean, like for example, if you have a voltmeter or ammeter or something, right? You need to calibrate it, that how much current will cause the needle to move by 10 degrees or things like that. So, and if you have that calibration, then you can draw the scale on it. So calibration in the camera also means kind of similar, that how much like if an object is 3 meters long in the 3D world, how big will it appear inside your image, which is captured by your own camera? So for that, you need to figure out some parameters of the camera. And then if you know the calibration of that camera, then how can you use that information to connect the pixels from 2 or more different images that are looking at the same object in the real 3D world. So those things will involve mostly trigonometry, which I think is very simple 11th 10th 11th standard trigonometry, and then some matrix multiplication and things like that. So it's actually not very hard. And then in lecture 4 and 5, we will talk about machine learning theory, how, you know, a few 2 or 3 different famous algorithms for different kinds of machine learning, how to extract features and information from images, and we'll also talk about deep learning. And in these 2 lectures, the main skills that we will use are also kind of 11 standard things, basically differentiation, chain rule of differentiation, and some matrix multiplication, things like that. And then finally, we'll talk about how to describe and how to control the motion of robots. So it can be a wheeled robot, like a 4-wheeled car robot, or it could be a robot arm like what you saw in that video, or it could be the fingers of that robot arm and things like that. So here also we will use very basic trigonometry and matrix multiplication and things like that. And then we will also talk a little bit about just a basic introduction about reinforcement learning, which is sort of like the very basics of it, just so you understand what reinforcement learning means. So just some details, as Pujara sir mentioned, I am planning to release homeworks after each lecture. They will all be completely in Python, and mainly you'll be using NumPy. I think pretty much everyone who uses Python knows how to use NumPy, but if you don't, then you can just search on the internet for tutorials about NumPy. And we won't even use any fancy NumPy features. It's just very basic. How to do matrix multiplication, how to extract some small part from a big matrix and things like that. Which is what I call basically linear algebra. And then in mathematics, we will use differentiation. And then as sir also mentioned, there is this website which right now is just, it just has all these empty links, but as we finish each and every day's lecture, I will update, it will be uploaded to YouTube. So the recording will be uploaded to YouTube, and I will update the link there. And we are going to use a feature called Google Colab, which allows you to run Python code just on the internet on servers that are provided by Google for free. So that makes it easier for us to share the homework and things like that. So the link for the recording and the link for the Google Colab notebook for that lecture. And there is a question about any software download. That is a good question. Let me think. Actually, if you just use this Google Colab, then you don't need anything. All you need is a web browser. But I myself, I don't have a lot of experience with Google Colab, so I think I'm 90% sure that I'm going to use Google Colab. But if we don't use it, then you just need to install Python on your computer. Basically, you just need to install Python, and you need to install NumPy. So I think that should be very simple. And yes, so the idea is there will be videos, so you can always go back and refer to all the formulas and things like that. You don't need to learn anything by heart. And at the same time, as I mentioned before, the just always send a chat or just unmute yourself and ask a question anytime in the lecture. Let me see if there are no other questions. Yes, I think that's it. So after each lecture, we will release that homework. It'll sort of be very simple things where you just need to write a few lines inside already provided definition of the function. And if you write the correct lines in there, then it will automatically be able to check whether your answer is correct or not. Is there any site you prefer to go through for all the topics? Not right now. I think basically if you just look at the lectures and things like that, that should be enough, because what I'm planning to do is actually basically like derive the formulas myself. So it'll kind of be like it'll be similar to someone teaching on a blackboard. So we will derive all the formulas ourselves, and you can just always go back to those lectures and things. And as I mentioned, these are all very basic concepts. So at the end of the lecture, I will share maybe some books or things like that with you if you want to pursue that in depth. So that I will share as and when all the lectures happen. What do we have to do in Python linear algebra? Basically just matrix multiplication. I think if you just know how to do matrix multiplication with NumPy, which is kind of the basic function of NumPy, then that's enough. We might use some eigenvectors, things like that. But also again, NumPy, there's already ready-made functions for calculating eigenvectors. So I think that should be very simple. And yes, I think that's it. That's it for today. And as I said, today there was no technical content. Just hopefully I've motivated you to be excited about this topic. And yeah, the first lecture will be next Sunday. We will talk about image formation and topics like that.